Section 2.2 is about the multiplication property of equality. Similar to the addition property of equality, the multiplication property says that if A equals B, then A times C is equal to B times C. That is, you can multiply both sides of the equation by a non-zero number and you won't change the trueness of the equation. So that is, we can multiply. And since multiplication and division are linked, we can multiply or divide. Division is also covered by this property. Oops, I was going to write divide. I was trying to write division. We can multiply or divide each side of the equation by the same non-zero number. So for example, in x divided by 7 equals 9, I would like to do the opposite operation of what's going on right there. This is x divided by 7, so we're going to counter by multiplying both sides by 7. When I multiply both sides by 7, I can see that 7 goes into 7 once, and it's going to leave me with 1x, so just the x, equals 9 times 7 is 63. So multiplying both sides by 7 allowed me to get that x by itself. In the next example, I need to get b by itself. Right now I have negative b. So I can multiply both sides again by negative 1, because I know a negative times a negative is going to give me a positive. Making sure that I multiply both sides by the same thing. So negative times negative is positive b, equals 7 times negative 1 is negative 7. Alright, in example C, it's 5 times x, so the opposite is going to be to divide by 5. So if I divide both sides by 5, 5 divided by 5 gives me x, equals 6. 30 divided by 5 is 6. Alright, again I'm looking to solve for x. This is negative 6 times x. Opposite of negative 6 times x is to divide by negative 6. So I'm going to divide both sides by negative 6. On the right hand side that gives me x. 2 negatives make positive, positive x right there. Now 6 is not going to 28. I'm going to make sure I reduce that fraction and put it in lowest terms. It will be negative since I had a positive divided by a negative. And I can divide both numbers by 2. That would leave me a 3 in the bottom and a 14 in the top. So my answer is negative 14 thirds. Alright, and the next one, I'm going to divide both sides by 5 ninths to get n by itself by negative 5 ninths. Or 5.9, I'm not sure why I said ninths. I was talking about fractions from the one before. So that was a multiplication by 5.9, and so I needed to divide both sides by negative 5.9. N equals, now for decimals, the decimal problem, I want to end with decimals, so I'm making my calculator. 25.37 divided by 5.9. I know 2 negatives, so this is going to make this a positive 4.3. Alright, back to fractions in the next one. So what I need to do here is divide by 5/6, but I remember that in order to divide with fractions, I need to multiply by the reciprocal. So instead of dividing both sides, reciprocal, kind of smushed there. Instead of dividing both sides by 5/6, I want to multiply both sides by the reciprocal. So I'm going to multiply by 6/5. That's how we divide by fractions. That'll have the 6's and the 5's both cancel and give me y equals, and this one I can cancel a little bit. I can cancel the 8 and the 6 by dividing a 2 out. And nothing else is going to reduce. So I'm going to have 3 times 3 is 9 on the top, and 4 times 5 is 20 on the bottom. So my answer for y is 9/20. Let's go on to the next page. Alright, in this objective we're going to use both the addition and multiplication properties. So when I'm solving for x, my first goal is to get the x term by itself, which means get rid of anything that isn't x. So I'm going to start by, since I've got a plus 2 right there, subtracting 2 from both sides. That'll give me 7x equals 21. 23 minus 2 is 21. Now I'm going to divide by 7 to get the x by itself. That gives me x equals 3. Let's try it in the next one. In this one I have two different x's. I can't solve for x if I have x in two different places, so I better start by combining the x's. Get all the x's on the same side, so let me just subtract 2x from both sides. That'll give me 4x plus 14 equals, when I subtract 2x, that 2x goes away, and I'm just left with negative 2 on the right-hand side. Now we're in a similar situation to part A. I know where the x's are. I want them by themselves. That 14's got to go. So we're going to subtract that 14 from both sides to move it. It's going to give me 4x is equal to negative 2 minus 14 is negative 16. And then divide by 4 to peel that 4 off of the x and get our x by itself. So x equals negative 4. Negative 16 divided by 4 is negative 4. Okay, let's look down at the next two. Okay, I notice on part C that I have like terms that need to be combined. So 3x minus 5x is negative 2x. Minus 2 equals 6. They're already on the same side, so I just subtract them like it says. Now, this 2, I want to move to the other side. When I'm moving it to the other side, I need to use the opposite operation. So I'm going to do the opposite of subtraction is addition. So I'll get negative 2x equals 8. And then it's negative 2 times x. To x by itself, we're going to divide by negative 2. So I get 8 divided by negative 2 is negative 4. Okay, in part D, again I start off with a situation where I have the variable on two different sides. So I'm going to need to subtract one of them. I can either subtract the 2w or the 6w. I prefer to move the smaller value because it will leave me with a positive value left over. So I've got, remove the 2w, so I've got negative 9 equals 6 minus 2w, positive 4w, plus 23. And again, I'm trying to isolate the w, so I'm going to get rid of the 23. I'm moving it to the other side of the equation with subtraction. So that's going to be negative 9 minus 23 is negative 32 equals 4w, and then divide by 4. So we find out that w is equal to negative 8. Okay, next page. Objective 4, solving applied problems using formulas. So in example 3, we've got a model here where P is the puppy's price in years after 1940. So if the trend continues, what is the price of the puppy in 2012? Well, first of all, since this is years after 1940, I have to figure out how many years it's been between 1940 and 2012. So let's subtract 2012 minus 1940. Okay, 2012 minus 1940, 72 years. So 72 is going to become the value that we're going to plug in for n. So the puppy's price, P, equals 18 times 72 plus 765. So back to the calculator. 72 times 18 is 1296 plus 765 is 2061. Or, yep, 2061. So in 2012, a purebred Westie puppy would cost you $2,061 according to this model. Part B, when will the price of the puppy be $2,277? Okay, so looking back over here at my model, $2,277 is the puppy's price, and what I'm looking for is the value of n. When is that going to happen? So I'm going to solve this equation for n. The first thing I need to do to solve for n is to get rid of this 765. It's positive, so we're going to subtract it from both sides of the equation. So that'll give us, on the right-hand side, 18n, and on the other side, 2,277 minus 765 is 1512. And then we're going to need to divide both sides by 18 to get that n by itself. That was 18 times n, so the opposite of times divide. Divide by 18 to get n by itself. So let's divide by 18. 84. Now remember that that is 84 years since 1940. So if I want to know what year that is, I'm going to add that back to 1940. So that's going to be 2024. So my answer is, in this one, in 2024, the puppy costs, or a puppy costs, $2,277.